Welcome back to the MySQL podcast from Kedar. Today, we're going to do a deep dive into something that might
Oh,
sound
yeah.
a little dry at first, duplicate and redundant indexes in MySQL. But trust me, this stuff is way more important
Absolutely.
than you might think.
Yeah.
We're talking about potential performance bottlenecks and wasted storage space, all lurking under the surface of your database.
It's true. Understanding these often overlooked indexes can really level up your database efficiency game.
Okay, so before we get into the why bad, let's make sure we're clear on what exactly these sneaky culprits are. We've got duplicate indexes and redundant indexes. They sound kind of similar, right?
They do, and they often get used interchangeably. But there's a crucial difference. A duplicate index is exactly what it sounds like. Two or more indexes that are absolutely identical, same columns, same order, the whole shebang. Think of it like having two identical copies of the same instruction manual. You only need one.
Right. So MySQL actually lets you create these duplicates without raising any red flags. That seems a bit risky.
Unfortunately, it does, and it can come back to bite you later on. You see, MySQL has to maintain all those duplicate indexes, so every time you update data, it has to update multiple indexes. That slows down updates and makes query optimization way more complex. It's like trying to find a specific diagram in that instruction manual when you have multiple copies scattered around, and you're not even sure which one has the notes you made.
Ouch, yeah, that sounds like a recipe for frustration. Okay, so how are redundant indexes different?
A redundant index overlaps in coverage with another index, often as a subset. Imagine you have an index on columns A and B, and then you create another index on just column A. That second one is redundant because the first index already covers queries that only need info from column A. It's like having the full index and separate index cards for each chapter title. Not very efficient.
So are we saying redundant indexes are always a bad thing?
Not necessarily. Sometimes that smaller redundant index on just column A might actually speed things up for very specific queries. It can be faster to look up just that one chapter title on its own index card, rather than searching through the whole book index.
Okay, so it's not a simple black and white situation.
Yeah.
But generally speaking, fewer unnecessary indexes are better for our database's health, right?
Absolutely. Besides performance, think of the storage space you save. By getting rid of these unnecessary indexes, it's like decluttering your digital closet and finding a bunch of space you didn't even know you had. That space can then be used for more valuable data. Plus, fewer indexes mean easier maintenance, less work when it comes time to rebuild or reorganize them.
Less work, more efficiency. Always a good thing. Okay, so let's say I'm convinced. My database is probably riddled with these unnecessary indexes. How do we even find them?
Thankfully, we don't have to do it manually. There's this awesome tool called PicT Duplicate Key Checker from the Percona Toolkit. It's like a detective for your database,
Yeah.
sniffing out all sorts of duplicate index issues.
Percona Toolkit. Gotta love open source tools that make our lives easier. So how does this detective work? Tell me more.
Well, it goes beyond just finding exact duplicates. It can also identify what are called left prefix duplicates, where one index is a prefix of another, like having an index on columns A and B, and then another on A, B, and C. The smaller one is redundant, because the larger one already has it covered.
Ah, so it's like having a map of a whole city
Yeah.
and then another map of just one neighborhood within that city. No need for both.
Exactly. And this tool goes even deeper. It checks for redundant foreign keys, which we won't dive into today, but it also finds something called clustered key redundancy in InnoDB. This is where it gets a little more technical, but it's super important, especially if you're using InnoDB.
All right, hit me with it and ready for the technical stuff.
Yeah.
What is this clustered key redundancy all about?
So in InnoDB, your primary key is what we call clustered. That means it's physically stored with each secondary index. So if you have a secondary index, it already includes those primary key columns. Adding the primary key again in that index is redundant and wastes space.
Hold on, let me paint a picture in my head. You're saying in InnoDB, the primary key is like a VIP with an all-access pass to every secondary index party.
Perfect analogy. Let's say your primary key is on a column called ID, and then you create a secondary index on columns A and ID. Well, because of that clustering in InnoDB, the ID is already part of that secondary index structure. Explicitly adding ID again is like sending a separate invitation to a VIP who's already on the guest list.
Ah, I see. That makes so much more sense now with the VIP analogy. And I can definitely see how all these little redundancies could add up to big performance hits, especially when dealing with large databases, where every optimization counts.
Exactly. And that's just the tip of the iceberg. Once we've identified these unnecessary indexes, the real challenge lies in safely removing them without disrupting your database's performance. But we'll save that discussion for the next part of our deep dive. Stay tuned.
All right, so we've identified these Sneaky, unnecessary indexes hiding in our database. Now comes the fun part, actually getting rid of them. But before we go on a deleting spree, I'm guessing there's a right way and a not so right way to do this.
You bet there is. While duplicate indexes are usually safe to drop right away, they offer no added benefit and just create overhead. Redundant indexes require a bit more caution.
So it's like cleaning out your closet. You can confidently toss those duplicate sweaters you never wear, but you might think twice before getting rid of that old jacket. That you might need someday.
That's a great analogy. With redundant indexes, it all boils down to understanding how your applications are using the database, what queries are running, which indexes are they actually relying on. This analysis helps you pinpoint the truly unnecessary ones that are safe to remove.
So before we even think about hitting that delete button, we need to do our homework and really understand our query patterns.
Exactly. And luckily, there are tools to help us with this analysis. MySQL's slow query log, for example, can be a goldmine of information. It shows you which queries are taking longer to execute and which indexes they're using. This can give you valuable insights into whether a redundant index is actually helping or just adding unnecessary baggage.
It's like having a detective examine the scene of the crime to figure out what really happened.
Precisely. And once you've gathered this intel, you can start experimenting with removing those redundant indexes. This is where the invisible index feature in MySQL 8.0 and later versions comes into play. It's a real game changer.
Oh yeah, we touched on that earlier. Tell me more about how this invisible index trick works. It sounds almost too good to be true.
It's a fantastic way to test the waters before making any permanent changes. Basically, you mark an index as invisible to the optimizer, which means it won't consider it when planning how to execute queries. But here's the key. The index is still physically there and maintained by the database.
So it's like putting a piece of furniture in storage. It's still there if you need it, but it's not cluttering up your living space.
Exactly. By making the index invisible, you can observe how your application performs without it. If everything runs smoothly, you can be confident that removing the index for good won't cause any problems.
Okay, that makes sense. But what if things start going haywire? After you make an index invisible, what's the plan then?
Well, that's a clear sign that the index was actually being used, and you might want to reconsider removing it. The beauty of the invisible index feature is that you can easily toggle it back on if needed, no harm, no foul.
It's like having a safety net for your database optimization efforts. You can experiment and make adjustments without the risk of breaking things permanently. I like that.
And that's a crucial aspect of database management, especially when you're dealing with live systems that need to be highly available and performant. Taking a cautious step-by-step approach ensures that you make informed decisions without jeopardizing your database's stability.
So we've talked a lot about the technical side of identifying and removing unnecessary indexes. But I think it's important to zoom out and look at the bigger picture for a moment.
I agree. What do you have in mind?
Well, it's easy to get lost in the weeds of specific tools and techniques. But the real takeaway here is that understanding your indexes is crucial for building and maintaining truly efficient database systems. It's not just about blindly adding indexes or deleting them without careful consideration. We need to be smart about it.
I couldn't agree more. It's about having that holistic understanding of how your indexes impact performance, storage footprint, and your database's overall well-being. It's about making informed decisions based on analysis and testing, not just gut feeling.
It's like being a chef who understands how each ingredient contributes to the final dish. You don't just throw things in randomly. You carefully select and balance each element to create something delicious and satisfying. Each ingredient has a purpose.
That's a delicious analogy. And just like a chef constantly refining their recipes, database folks should always be looking for ways to optimize their indexing strategies. This might mean adding new indexes to speed up queries, removing unnecessary ones to reclaim space, or even restructuring existing indexes to better fit the application's needs.
It's an ongoing process, not a one-time fix.
Exactly. As your database grows and changes, so too should your approach to indexing. It's all about striking that perfect balance between performance efficiency and maintainability.
Well said. Now, we've talked about what to do with these unnecessary indexes, but I'm curious about what not to do. What are some common mistakes people make when it comes to managing indexes? Where do things tend to go wrong?
That's a great question. Even with the best of intentions, it's surprisingly easy to fall into some common traps when managing indexes. And these mistakes can lead to performance bottlenecks, wasted storage, and even data inconsistencies. Things we definitely want to avoid.
So let's shed some light on these potential pitfalls and help our listeners steer clear of them. What are some of the biggest indexing blunders you've seen?
One of the most common mistakes is over-indexing. It's tempting to think that more indexes always equal better performance, but that's just not true.
The classic more is always better fallacy strikes again?
Exactly. While indexes speed up those read queries, they also come with a cost. Every time you update data, the database has to update all the relevant indexes, which can really slow down write operations. Too many indexes can be like having too many cooks in the kitchen. They might end up getting in each other's way.
So it's all about finding that sweet spot, the Goldilocks zone of indexing. Not too few, not too many, just the right amount for the job.
Absolutely. Another common mistake is indexing every single column. Not all columns are created equal when it comes to indexing. Indexing columns that are rarely used in queries or that have low cardinality won't give you much benefit and can actually be harmful.
Hold in low cardinality. Can you unpack that for us?
Sure, cardinality just refers to how many unique values are in a column. If a column has very few unique values, like a gender column with only male and female, an index on that column won't help much. It's like putting an index in a book that only has a few pages. Not very useful.
Ah, that makes sense. So we want to focus our indexing efforts on columns that are frequently used for searching and sorting, the ones that will actually benefit from an index.
Precisely. It's about being strategic, not just indexing everything in sight. Now, here's another mistake people often make: using the wrong index type for the job. MySQL offers different types of indexes, each designed for specific situations. For example, B-tree indexes are your workhorses, great for general-purpose indexing, while full-text indexes are specifically for searching through text-based data. Using the wrong index type is like trying to hammer a nail with a screwdriver. It might work, but it's not ideal.
So choosing the right tool for the job, or in this case, the right index type is essential. Any other common blunders we should be aware of?
Yes. One that's often overlooked is not regularly monitoring and maintaining those indexes. Over time, as your data changes and queries evolve, your indexes can become fragmented or outdated, leading to performance dips.
So it's not a set it and forget it kind of thing. Index maintenance is a crucial part of keeping the database humming along smoothly.
You got it. Regular index maintenance is like giving your car those regular two-ups. To keep it running smoothly, might involve things like analyzing index usage, rebuilding fragmented indexes, or even reorganizing them to optimize their structure.
And I imagine that ignoring those maintenance tasks could lead to some pretty big headaches down the road.
Exactly. Just like neglecting your car's maintenance can lead to costly repairs, ignoring your indexes can result in performance issues and a lot of unnecessary frustration.
Okay, so to sum it all up, we need to avoid over-indexing. Be choosy about which columns we index. Pick the right index type for the task, and make sure to give those indexes some regular TLC. It sounds like there's a lot to consider.
It's true, effective index management does require attention to detail, but the good news is by understanding these common pitfalls and taking a proactive approach, you can really unlock your MySQL database's full potential and make sure it's running at its best for years to come.
Love that. So for our listeners who are ready to take their MySQL indexing game to the next level, where can they go to learn more and dive deeper into best practices?
The official MySQL documentation is a fantastic resource with tons of detailed information on index types, creation syntax, and maintenance tasks. And if you prefer a more hands-on learning style, there are some excellent tutorials and online courses available.
And of course, never underestimate the power of community. There are tons of MySQL forums and online groups where you can connect with fellow enthusiasts, swap stories, and get advice from seasoned pros.
Absolutely. The MySQL community is incredibly vibrant and supportive, so don't be shy about asking questions.
Great advice. Well, I think we've covered a lot of ground today. We've gone from the basics of what indexes are all the way to the finer points of managing them effectively. Hopefully our listeners now have a much clearer understanding of this often overlooked, but critical aspect of MySQL database optimization.
I hope so too. And remember, indexes are powerful tools when used wisely. By taking the time to learn how they work and how to manage them effectively, you can unlock significant performance gains and keep your database running like a well-oiled machine.
Well said. As we wrap up our deep dive today, I want to leave our listeners with one final thought-provoking question to ponder. Knowing what you now know about indexes, take a good look at your own MySQL databases. Could there be any hidden performance bottlenecks lurking in the shadows, disguised as duplicate or redundant indexes?
That's a great question to consider. And remember, even if you think your databases are perfectly optimized, there's always room for improvement. The world of MySQL is constantly evolving. So stay curious, keep learning, and keep experimenting.
Couldn't have said it better myself. Thanks for joining me on this deep dive. It's been a blast as always.
The pleasure was all mine.
Until next time.